Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to my channel. I'm Minhazur Rahman. I'm an educator. I facilitate my students into learning chemistry, biology, and English. Today we're going to discuss about principles of chemistry, states of matter. The learning outcome of today's video is understanding the three states of matter in terms of the arrangement, movement, and energy of the particles. So the three states of matter are solids, liquids, and gases. The solids have a rigid structure. The particles are close together. The liquids have a fluidity in them, and the gases have a random motion. They have a lot of space between the particles and they can move in all directions. In order to explain the states of matter, we usually use the kinetic particle theory of matter, which is a model that describes the arrangement, movement, and energy of particles in a substance. The model is used to explain the physical properties of solids, liquids, and gases. This means that today we are not going to discuss anything about the chemical properties or chemical bonds. We are not going to discuss ionic bonds, covalent bonds. Rather, we are going to discuss the physical properties of solids, liquids, and gases, the three states of matter. How are the particles arranged and how do the particles move? On the header, as you can see, we have the solid, liquid, and gas, and the closeness of the particles. The solids are very close together, as you can see in the diagram. Liquids are close enough, they're close, but they can move around each other. Gases, they are far apart, right? Gases, they can move in all directions, they are randomly arranged, they move quickly in all directions, they have the highest energy, whereas the liquids, they have somewhat greater energy than solid, but they are in the middle, right? The solid, they don't have as much energy as liquids, and the gases have highest energy. The solid particles are able to vibrate around a fixed position, whereas in liquids, the particles can move around each other. Particle arrangement and movement. In terms of relative energy, gas particles have the most energy, solid particles have the least energy, and liquid particles are somewhere in between. You need to compare all of these at the same temperature, because temperature provides energy, and if you're considering the three states of matter in different temperatures, then the comparison will not be valid, because at different temperatures, the elements, all the molecules are going to behave in a different way, right? The states are going to be different. The particles in the diagrams could be atoms or molecules or ions, depending on the type of substance. Example, ionic bonds, simple molecules, giant molecules, and metals. Again, I want to give a reminder that none of these physical properties are dependent on these bonds, rather it's more dependent on intermolecular forces. We need to discuss intermolecular force. Yes, we will be discussing this in a future video, inshallah. Explaining the properties of solids, liquids, and gases. Solids, they have a fixed volume and a fixed shape. They cannot flow because their particles cannot move from place to place. They cannot be compressed because their particles are close together and have no space to move into. Liquids, on the other hand, have a fixed volume but no fixed shape, which means they can flow and take the shape of their container because their particles can move around each other. They cannot easily be compressed because their particles are close together and have no space to move into. Gases, however, have no fixed shape or volume. They can flow and completely fill their container because their particles can move quickly in all directions and can be compressed because their particles are far apart and have space to move into. One of the uses of this property of the gas, an example can be carbon dioxide. Carbon dioxide is a gas. It's used in fizzy drinks. It's the carbon dioxide that causes the fizz in the fizzy drinks. fire extinguishers. Carbon dioxide is compressed into containers, and when there is a fire, what we usually do is we allow the carbon dioxide to move out of the container and disrupt the contact between the fuel and oxygen. Carbon dioxide being heavier, it displaces the oxygen and it doesn't allow the oxygen to come into contact with the fuel, so it extinguishes the fire. In fizzy drinks, carbon dioxide is soluble in high pressure, so it dissolves in the liquid, and once you open the cap, the pressure is decreased, and so carbon dioxide moves out of the solution, causing the fizzing. So this is like, why are we learning this? Yes, these can be some examples. Why are we learning the states of matter? In the next video, inshallah, we will be discussing the interconversions, evaporation, condensation, sublimation, and how they are achieved, the changes in arrangement, movement, and energy of the particles. That will be all for now. See you in the next video, which will be uploaded tomorrow, inshallah. So see you tomorrow, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.